But the values for this, PC and CO, are determined up here. Okay, so PC has a default of 16, which is some sort of character. We'll take a look. And CO has a default red. Okay, so all you need to call this function is a set of x's and y's. So let's read the function in. So we'll read the function in. We do that. And so now we've got our function in there. And let's do it again, make sure we don't have any values at all in our workspace. So the workspace is clean, and we'll get rid of this histogram of the Nile. That's clean. And we read this in. So here's our function. We got our function. There's no variables at all in the global environment. Okay, now we call it. We call the function. What's this? This is a vector. This is the sequence operator. So x is the vector 1 to 10. Y is the vector 1 to 10. So we're calling the function, there's x, there's y, and x gets this value, y gets this value. What happens when we do that? It draws a scatter plot of points. And it's a straight line because x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so is y. So it's a 45-degree line. They're red, and they're little filled-in, not circles, they're kind of squash circles. Why are they red and squash circles? Well, let's go back and look. Because we didn't pass in a value for this fourth argument, it was empty here, it was 16. And 16 is the plotting character. It's that filled in little shape. I don't know what this is called geometrically. It's not circle, but it's not a rectangle. And the color is red because we did not pass in a value. So it got this default color. And to call the function, that's all we need. We need to have x's and y's or it won't work. Okay, well, what happens if we, let's call it again, but this time we'll just say 1 to 10, 1 to 10, and then we'll add this, 17. Does it work? Let's see. So we run it now, and it does. The function executes. We get the same plotted points. They're still red, but instead of flat little circles, we've got little triangles. Why are they little triangles? Well, let's take a look. So we come back up here, and we see, we know why we got 1 to 10, 1 to 10. PC, in this case, it looked at the calling arguments, there are 3 calling arguments, and it will assign the values in order. That is, it doesn't see the name PC, but it says, okay, well, here's the third one, it's 17. So now I'm going to make PC equal to 17. So when it executes the body, PC has a value of 17, and that's the plotting character, this little triangle. So the color is still red. Okay, well, what happens if we do this? Okay, note we have 4 formal arguments, and the last one, the fourth one, is the color. What happens if we skip the third one and we just say CO is navy? Will it work? Let's give it a try. So we run it, we call it that time, and it does. We get navy blue plotted characters, but they revert back to that default shape, the squash filled in circle. And that's because we didn't give it a value for the plotting character. So when it called the function, it used the default value in the definition. Well, what happens if we, let's do this. So let's do it one more time, and we'll call it with all 4, but we'll we'll just put 15 in here for the value of the third argument, and we'll use the string without the name green. Let's see, will that work? It does. This is the flexible evaluation of arguments. R is very flexible. Okay, so they're squares, though. We've got little green squares. Well, why is that? Well, let's go back and look. Well, it instantiates the values of the formal arguments in the order that they're encountered in the calling function, in the call of the function. So this is the third one. So 15 just simply gets assigned to this. The string green gets assigned to this. Well, let's take this further. What happens if we change the order? We don't use the names of the formal arguments, and I've repeated the function here so we can see it. Okay, so here's the function again repeated. And instead of using names, I just put the values of the arguments, but I get mixed up and I mess up the order. Okay, so I've got green, 3, and 15. What happens? Will it work? It actually does succeed, but it doesn't do what you think. And you might not even be able to see this. I don't know. Can you see this? What we have are little yellow G's. The character G in yellow, lowercase. That's the plotting character. Well, how did that happen? Go back and look at the function. Well, PCH and color in the plot, in the plotting formal definition of plot and the base graphics, can accept as values either numbers or a string. You can use a number to refer to a color or the string to refer to the color. But we messed it up. Okay, we meant green to be matched with the fourth one, and we meant 15 to be matched with this one. And we inadvertently messed up the order. But it still worked. Why is that? Well, 15, it assigned 15 to this because they're both in the fourth position. 15 is yellow. It's a yellow color. PCH can accept either a number or a single character. So it looked at this string object, matched it with this, and it said, well, I can use the first character, G. It discarded the rest, and it said, okay, I'm going to use G as the plotting character because PCH will not accept a string of more than one character. Okay, so it worked, but not for the reasons you think. We can fix it. Note that you can call a function in any order. You can reverse the orders of the arguments as long as you name them. If you call the functions using the name in the formal definition, that is, the order is unimportant. Okay, so what happens if we do this? Well, if we do that, then it works. We get little green squares. What's the point of this? Well, a couple of things. First of all, whenever you're writing a function, if you're defining a function, especially if it's more complex, if it's a function you're going to keep and it's got more than one or two arguments, as most of the functions do, you want to give some thought about the names and the default values of arguments. You obviously cannot give default values to every argument in your function. If you could do that, there'd be no purpose of having a function. The purpose of a function is so somebody can pass data into it and the data gets manipulated. That's the essence of a function. It takes data as input, it transforms it in some fundamental way, and then it exports the transformed data. That's what a function is supposed to do. So if you could hardwire all of the arguments, there's no point in the function. But if you can determine most of them, especially arguments that the common everyday user might overlook or be unaware of, it makes the function better. The function won't, it's unlikely people will mess it up. And it makes the function easier to use. All they have to do to use it is be aware of the arguments that do not have default values. Okay, so that's one thing. Now, we'll talk about that more. Let's here we got time. Let's look at one more. This is a more complex example. This is a fun example. Here's another feature of functions. Functions have the lazy evaluation, or the flexible. This is another example of the extreme flexibility you have of calling functions, writing functions, calling functions in R. This is not a mistake. This is the triple dot. This argument, this is a formal argument, triple dot. And what triple dot means, it has another name too, but I can't remember what it is it's referred to as triple dot, but it has another more, I don't know. But what it means is, and it's common in some other languages, I can accept anything, any type of arguments, any number of arguments will work. I have not named anyone. I've not named any arguments. It's just an open list. You can pass in any arguments of any structures, anything. And I will begin to execute the body. It does not guarantee that you won't get an error. It just makes it easier to call the function with different sets of arguments. Well, okay, what does this function do? Well, let's take a look. It's called many means. What many means is supposed to do, it's supposed to accept any number of vectors of different lengths. And it's supposed to return for each vector, the mean and the variance. Well, how can we do that? I mean, just quickly think about the possibilities. You know, what if you input a vector that's 5 long, you input a vector that's 10 long, and a vector that's 15 long? How's it going to handle all of those? Well, it does. What happens if you put in a vector that doesn't have numbers in it? How's it going to handle those? Well, it won't return the means, but it will deal with them. Let's take a look at what happens. In this function, the first thing that happens when we get to the body is it sweeps together whatever is passed in here, and it creates a list out of them. This is what lists are really good for. You can think of a list, it's like a garbage collector. You can pick up all of the objects, disparate objects, different types, lengths, everything, bind them up into a list.